Now we're going to study the potential difference in a uniform electric field when we are moving from a point A to B, which is at an angle theta, to the electric field. So the displacement is from A to B at an angle theta, and suppose that this displacement from A to B is a vector, S vector, which has a magnitude of S magnitude. Okay, this vector has a magnitude of S magnitude. This distance is S, it means. So if you have to find out what is the potential difference between the 2 points A and B, then delta V vector will be given by minus integral of E vector dot ds vector. So here also we are having a uniform electric field. So because it is a uniform field, we can take electric field outside and it will be ds vector and a dot product. You can also take dot product first and then take electric field outside, and you can also do like this. So it will be electric field dot, because you know that we know this vector and it is S vector. So delta V vector will be given by this. Now let's say that in the first case, the angle between electric field and displacement vector is theta. Then delta V will be given by minus Es cosine of theta. Now in this triangle, if I have to find out what is cosine theta, it will be d upon S magnitude. So d will be equal to S cosine theta. So let us replace it here, and what we get is minus Et. And what is delta V? When theta is theta, it means that we are moving from A to B. So it will be VB minus VA. Now in the second case, let us say theta is 0. It means that we are moving from A to C. And if theta is 0, delta V will be equal to minus Es cosine of 0. But what we have to take care here is the displacement. So we cannot use it actually. We'll have to take care of the displacement. So let us use the original expression, which is this. So electric field is uniform, we take it out. Theta is 0, so it will be integral of ds. Okay, so I hope you understood how cosine of 0. Okay, so this will be equal to 1. So we are just left with EDS. And electric field is uniform, take it outside. So what is the total displacement when we are moving from A to C? The total displacement is D. And this is VC minus VA. So it means that if you move from here to here, the potential difference is minus ET, and when you move from here to here, it is also minus ET, the same potential difference. Now let us see what will happen if you move from C to B. So in the third case, theta is equal to 90 degrees, and the potential difference will be minus integral of E vector dot ds vector. So now in this case we are moving from C to B, so but the angle is 90. So because of this, what you will get is EDS cosine of 90. So it will be equal to 0. So what it means is that the potential at B minus potential at C is equal to 0, or potential at B is equal to potential at C. So what do we understand from all these results? It means that whenever the motion is perpendicular to electric field, the potential is constant. So if the electric field is in this direction and you are moving in this direction, so this is electric field and displacement vector is along perpendicular to the electric field, then in this case the potential will always be constant. At each point, if it is V here, it will be V here, it will be V here on this surface, okay? And it means that the potential will be constant on a surface, and this surface is called equipotential surface. Equi for equal potential surface, a surface on which the electric field will be zero. So we can draw a surface perpendicular to the electric field.